Friday night is high school football night across the United States. But with growing evidence of the long-term effects of concussions and repetitive hits, parents are thinking twice about letting their children play. One problem is that there's currently no way to make an accurate sideline assessment of someone suspected of having a head injury. A recent study published in the Journal of the American Medical Association revealed that nearly 1 in 3 adolescents who play contact sport report having had concussion. So that puts pressure on sport trainers like Ben Zoziki at O'Dare High School in Seattle to make the right call when there's a clash of heads.
We know the long-term effects with concussions, and we have a better understanding on how they presented and how we manage them and the effects with school and just quality of life. So there's a huge concern nowadays.
So why don't you go ahead and look straight at my nose here, and I'm going to flash a light.
Medical professionals have long used a pen light to test the pupillary light reflex, but it doesn't reveal subtle changes in pupil response undetectable to the human eye that may indicate milder concussions. University of Washington neurologist Dr. Lynn McGrath has worked with the University of Washington's Computer Sciences Department to devise a smartphone app which can deliver an almost instant diagnosis.
The current standard of care is missing half of all patients with concussions. And there's no real good objective way to diagnose concussions. And I think that part of the problem is that the only technology able to evaluate the pupillary light reflex previously is this very expensive piece of equipment. So we wanted to find a way to make that diagnosis and give that ability to people using a very cheap device.
Taking inspiration from the pen light and working with a team of colleagues, they came up with Pupil Screen, a smartphone-based diagnosis app.
The app is able to be a lot more accurate and detect much more subtle changes than the human eye can, even that of a practiced clinician.
We have constructed an algorithm that goes through this data and tries to continually improve itself at being able to predict what a pupil size is.
Pupil Screen works using the stimulation of the smartphone's flash to measure even the smallest changes in someone's pupil, providing results on the phone screen in seconds. A small clinic-based pilot study earlier this year demonstrated almost perfect diagnostic accuracy for Pupil Screen, and there are plans for field tests in the near future.
So our hope for Pupil Screen is that it will become a part of the current protocol that players who are suspected of having an injury go through.
It'd be very useful because it's very easy. It'd be very easy to use, and also get reliable data from that app to help kind of make your decision on diagnosing concussion or not.
The NFL, the most popular U.S. sports league, is paying $1 billion to settle legal action by retired football players diagnosed with concussion-related conditions like chronic traumatic encephalopathy. CTE is common in ex-boxers and has been linked to progressive memory, behavioral and motor impairment. In the UK, a study will begin in January into whether heading a soccer ball can cause brain trauma. As more people shoot pictures and videos from consumer drones, researchers in Singapore have found a way around the frustrating task of framing and taking photos while manually piloting the craft. Research firm Gartner says more than 2.8 million consumer drones are expected to be sold this year, up from 2 million last year.
So we want to enable a more intuitive and natural interaction with the flying drones to take photos autonomously, even for the noise user that haven't used drone before, but we know how to use smartphones to take photos today. So we want to mimic the similar strategy to take photos using the smartphone cameras today, and then we want to port it to a flying drone.
Their innovation called X-Pose works in several stages. The user tells the drone to take photographs from different angles of the subject, such as statue. Next, the shot is composed by moving objects on photos from a sample gallery. Then the drone finds the best position to take the commissioned photo. No manual piloting of the drone is needed. The researchers from the National University of Singapore said their prototype based on a Parrot Bebop quadcopter, relies mainly on a single monochrome camera and works reliably even when there's no GPS signal. Some remotely controlled drones take the cue from Global Positioning System Satellite or GPS, which requires the drone pilots to know where the image is in respect to the drone, adding another layer of complexity to the process. But Expose does away with that. The researchers say it had a higher success rate in photo-taking tasks than the usual touchscreen joystick interface.
Military uses, hopefully it's not. I like peace. And of course, the technology is basically a tool. And because we develop a tool that can let the drone understand how the environment and what are the objects of interest, this technology could be used in other ways.
But the problem is a thorny one, he says, adding that he and fellow researchers went through dozens of methods and environments to evolve a working prototype. Several companies are working to simplify how users take airborne pictures and videos. A US-based startup, Skydio, which aims for flying cameras without the complexity, is working on a drone that follows its operator using onboard cameras to capture a 360-degree view of its environment. Another firm, Squadron System, offers an autonomous flying camera called Hexaplus. A user can program it via a smartphone app with simple instructions such as follow or hover close. The Motor Group offers the Lily Next Gen camera drone that flies itself and hovers above the user, taking photos and videos.